So we are now looking at the oceans to tap into more forms of energy and use existing ones in a more sustainable manner. We derive about 40% or just under 40% of our energy from the oceans. It is not a particularly well advertised fact. For our energy needs, humankind uses the oceans to get the oil and gas in the main. But now we're looking to the oceans also to give us energy of a sustainable variety, energy from the wind, from the waves, from the current, from the tides.
You know, I'm an earth scientist. I'm looking at how rocks react with chemicals. That's called water-rock interaction. We basically looked at one type of rocks, mantle peridotite, and they are usually 40 to 60 kilometers below the Earth's surface or below the oceans. And in some places they are on continents and react there with CO2, so convert that CO2 into calcium magnesium carbonate, basically limestone, and we are discussing to learn how is that reaction happening in nature, but then to learn from nature how to do it and to speed it up in an engineered version. It's basically taking permanently CO2 out of the atmosphere and producing rocks.
How we get the energy requires an understanding of the fundamental science. Getting the energy and transporting it to land requires an engineering solution. We need to do this in an economically viable manner within legal and safe frameworks.
Thinking out of the box will really help to open new funding resources, open new collaboration, for example, with industry, and find new solutions.